everyone. In this video, I'm going to be going over number, moles, and mass. This is such bad handwriting. I'm just like Professor says, I don't get paid for my handwriting. I actually don't get paid at all. I'm doing this out of my own entertainment so that I can study and that I can help other people while I study. Because personally, like, it sounds weird, but like the easiest way for me to study is for me to teach other people how to do it. That's how I've always been for some reason. But yeah, I figured that this would be helpful. But anyways, my handwriting is really bad, and that's the moral of the story. So we're going to be focusing on how to find the number of atoms present in something, given like the amount of molecules, how to find the number of moles in something. We don't go over that. We do atoms, grams, but and then finding out the mass, right? To find out the number of moles, you just do dimensional analysis. But yeah, so let's go over this one and I can show you kind of my like walk through that, and then I'm going to do a practice problem, and then that will be the end of the video. So let's look at number one. How many atoms are present? Oh, how many atoms of oxygen are present in 27 of these molecules? So that's hydrogen peroxide, if you didn't know. There's actually a joke with it. I guess I'll tell it. It's one of those two guys walks into a bar. Professor Sherlock's probably going to say this, so I'm sorry if I ruined it for you. Two guys walk into a bar. One person says, "I'll take water," which by the way looks like this. And then the other guy says, "I'll take H2O2. Or no, God, I messed up the joke. He says, "I'll take water too." So it's water 2. And this guy dies because he literally drank hydrogen peroxide. And then the joke is like, why did he die? Because if I said the joke right, it would have been funny. Okay, anyways, let's look at number one. So we're going to do some dimensional analysis here, right? So we're looking at 27 H2O2 molecules because we always start with what we're given when we're doing dimensional analysis over 1, right? So 27 H2O2 molecules, and we want to get to atoms of oxygen. So in one molecule of H2O2, O2, there are 2 atoms of oxygen. And we know that because right here it tells us that there's 2 oxygen in each molecule. So we're going to do that math, and it is going to be 54. 2 times 27 is 54, and then we're going to write atoms of oxygen. So we're going to write 54 atoms of oxygen. Awesome. All right, on to number 2. Again, we're going to start with what we're given. So it says, how many atoms of oxygen are in 32 moles? Keep in mind, we're talking about moles now, so we're probably going to see Avogadro's number in H2O2. Okay, so start with what we're given. 32 moles H2O2. Okay, divide by 1. And now what we want to get on top is atoms, right? So on the bottom, we want to cancel out moles. So we do 1 mole of H2O2. We're going to do molecules first, and then we'll go to atoms. So we'll do 1 mole of H2O2 is equal to 6.022. 022 times 10 to the 23rd. If you're not good with memorizing numbers, like, this is ingrained in my head after taking AP chemistry. But like, if you think you're gonna have trouble with this, it's definitely a good thing to add to your 3x5 index card. So this is 6.022 molecules. Again, and you can remember that because a mole of something is always going to be 6.022 of that thing, right? So say that I have 1 mole of cars. You have 6.022 times 10 to the 23rd cars. So a mole of H2O2 is 6.022 times 10 to the 23rd molecules of H2O2. And they found that number. Avogadro must be a crazy man. He calculated how, I think Professor Sherlock talked about this, but basically it was like how many molecules they needed in order to weigh it on a scale properly, and he found that it was 6.022 times 10 to the 23rd. Chemistry is one of those weird things that as soon as they discovered some way to do it, they just stuck with it. They're like, if it ain't broke, don't fix it. STEM subject. So there's some old stuff in there that like maybe they could fix up, but they just choose not to. Okay, so once we have that, we want to cancel out the molecules. So we know in one molecule of H2O2, O2, there are 2 atoms of oxygen. So same thing as before. We're looking here. 2 atoms of oxygen. Cool. We're going to now put that into our calculator. So we're going to do 32 times 6.022 times 10 to the 23rd. Big number. Times 2. I'm going to fix my calculator here so you can make sure we can get the right number. What I did there is I put parentheses between this number in my calculator because sometimes it'll like do like this times that. Things get messed up. So I always say to put that in parentheses just to make sure your calculator is doing the right thing. And I got what were we given? We're given 2 sig figs, so we'll go to 2 sig figs. 3.9 times 10 to the 25th. So 3.9 times 10 to the 25th. Okay, next one. How many grams of H2O2 are in 3 moles of H2O2? Okay, so we're going to do 3 moles of H2O2 divided by 1 times in 1 mole of H2O2. You could either use the periodic table for this or you could just go off of your memory if you know, but here's the periodic table. In oxygen it's 16, and here we have 1, so we have to find the molecular weight here. So we're going to do 2 times 1, so 2 times the molecular weight of 1 hydrogen, plus oxygen, which is 16 times 2, because we have 2 of them, and we're going to get 34. 34 grams of H2O2. So then we just do 34 times 3, and there's our answer. 102 grams of H2O2. Oh, this is supposed to be atoms. Oxygen. Atoms, oxygen. Oh my, I did not spell that right. Toms. Okay, H2, grams of H2O2. Cool. Okay, so that's how you do that. So I have a practice of that on here. If you guys would like to try it out yourselves, pause the video now and you can try it out. If not, I will be explaining it in 3 seconds. Okay, I didn't actually count, so I'm hoping that was 3 seconds. So how many hydrogen atoms are in 30 molecules? So we do the same thing. 30 molecules divided by 1 times. Now we ask ourselves, how many hydrogens are in 1 molecule, right? So let me just distinguish that I'm talking about H2SO4. In 1 molecule of H2SO4, we have 2 hydrogens. So 2 hydrogens, yay, is equal to, I guess we could say 2 hydrogen atoms if we want to be specific. So let's just check. We're crossing that out, and we're crossing that out. Yay. What we want is on top. Cool beans. I shouldn't have to put that in my calculator. 2 times 30 is 60. So we get 60 atoms of hydrogen. Okay, next one. How many hydrogen atoms are in 30 moles? So again, we start with the given. 30 moles divided by 1. Let me write that out. H2SO4 times our favorite number, Avogadro's number. So we're going to do 1 mole of H2SO4, 6.022 times 10 to the 23rd. Just a reminder that this is a 6. I started drawing a 2, but then I tried to fix it. But yeah, so this is molecules of H2SO4 times Okay, now we do the same thing. 1 molecule of H2SO4 is gonna have 2 hydrogen atoms, 2 H atoms. Alright, we can check again. We're crossing out moles, we're crossing out moles, and we're crossing out molecules, and we're crossing out molecules, and we're left with what we want. So that's how we know we did it right. And what are we gonna get when we put it in the calculator? So we do 30 times 6.022 times 10 to the 23rd times 2. We get 3.6 times 10 to the 25th. I'm only doing 2 sig figs because technically you're only given 1 sig fig here, but we'll say that we got 2 because we'll add the decimal point on there so that I can get some nicer calculations. 3.6 times 10 to the 25th hydrogen atoms. Alrighty, on to the next one. How much does 20 moles of H2SO4 weigh? So we have 20 moles of H2SO4 divided by 1, and in 1 mole of H2SO4, we're going to figure out how many grams there are. So there's 1 gram in a hydrogen, so there's 2 of them. So we're gonna do 1 times 2, which is obviously 2. And then in sulfur, I never remember sulfur. If you've watched all these videos, I've said that a million times. We're gonna do that plus 32.065 plus 4 oxygen, so we're gonna do 4 times 16 or 15.99, whatever you choose. Okay, and I got 98.065 grams in H2SO4. So this is going to then equal that times 20, which is it's 1961.3, but technically we have to round this up to do sig figs. So we'll make this 2,000 grams of H2SO4 just to satisfy the sig figs. But that is the answer that my calculator got, so oops. So whichever one, the amount of sig figs you get. Alright, so that is the end of this video. I hope that you all enjoyed, and I'll see you in the next one. The next video we're going to be talking about stoichiometry, so everyone's favorite. It's all just dimensional analysis, if you really think about it. So see ya.